Welcome today. My name is Boyan, and today we are going to talk about Angular. Let me see first, how many of you have been using Angular? Okay, that's great, most of you. How many of you bought a book about Angular from the guy here at the conference? Okay, just a few of you, because actually when today I went there and I wanted to buy a book, and he asked me, hey, I saw that you are speaking, what are you going to speak about? And I said, Angular. I said, oh, I just sold like most of my books about Angular, so be prepared. But apparently these guys who bought the books, probably they are somewhere reading it and not here. But anyways, today I'm going to talk about Angular 2, which is the version coming hopefully the end of this year or later this year. But the point that I want to make here is why we have Angular 2 and how it ended up there. So I'll take a bit historical approach. So basically, I'll start from how Angular actually evolved, how it emerged, what happened, and why we have Angular 2 and why we have this version exactly that we can see later today. I'll make some comments about it. Feel free to interrupt me, ask questions while I'm presenting, or if you prefer, you can take some notes and ask me at the end of the session. I'm totally fine with both of these. Just a couple of words about me. As I told you, my name is Boyan. I've been working, at least in the couple of years, mainly in the IT consultancy sector. So basically, the company that I work for, it's a very small company, and we do projects for other companies. Very simple concept, but what I like about my job is that I have the freedom and the opportunity to play with different libraries, with different tools, and when we have a problem at later point, this helps me actually to think about, okay, what tools I have in my tool set, which is the best tool that can help me in this situation. So in this case, I really like what I do. I'm once in a while doing like some talks like this here at some conferences. I also do some talks at the university. So basically, this is kind of like my hobby because I like meeting new people. I like discussing ideas. So I really hope that if you come with some crazy comments about what I tell you and what I do, or maybe you want to share something that you think it's really cool, I'm really happy to hear it and to discuss it with you. In my free time, I am doing something completely different, actually, as well. Doing improvisational theater. How many of you have been to improvisational theater or know what it is? Okay, just a few of you. Well, basically, the idea is that it's like a normal theater. You get on the stage, but there is no script written in advance. So how it works is the actors, they ask the audience for some random word, whatever you can say, and then they start acting based on this word. So they make a full performance based only from one word from the audience. But hopefully today I'm not going to improvise. Everything that I say is only based on real facts and figures. So no worries, I'm not going to lie much. So let's get started. How did everything start with Angular? These two guys, Mishko and Adam, they were just ordinary developers many years ago. And in their free time, they needed some tool to help them. They needed a tool to help them to bring the backend with the front end, basically doing some data, rendering in. So they decided, OK, why not just build some tools that could help us to achieve our goals and to save us time and efforts, of course. So this is why they wrote their first project, which they called Get Angular. And they were using it, of course, in their free time. At some point, Mishko started working in Google. And there in Google, he was working with Google WebKit. So we got a project. And together with two other developers, for around 6 months, they were using Google Web Toolkit. And they managed to build, like to write 17,000 lines of code for that particular project. Then Mishko got really irritated about the quality of the code because it got really complex, really hard to maintain and edit afterwards. So he said to his manager, hey, boss, listen, I have this cool project that I'm doing in my free time, and I bet with you that I can rewrite this code only in 2 weeks with my project. Unfortunately, he couldn't do this. because he used 3 weeks for this project. And he reduced only himself the code to 1,500 lines. Well, apparently his manager was very impressed, although he couldn't win his bet. But his manager was very impressed, and this is how Google took over Angular and started developing it internally and using it more and more internally. So what happened with Angular afterwards? So this here is a Google Trends chart. You know that you can go online on Google Trends and just try to see how a specific search term has been used in Google. So this is here comparison between, let's say, AngularJS, Knockout, Backbone, Ember. And you can see that from around, let's say, 2011, then we get this line going up. So the blue one is actually Angular, while the other ones here are the other three. So from around 2012, Angular has been grown really rapidly. A lot of people searching, a lot of courses online, a lot of books, tutorials. This here is LinkedIn skills. You know that in LinkedIn you can put some skills. So maybe after this topic or after you read the book about Angular, you can also add it if you don't have it already. But basically, this shows what people are actually using. So we have the Angular around 100,000 and more people have put AngularJS as a skill on LinkedIn compared to Backbone, Knockout, and Ember. So it's really, really popular, and a lot of people are adopting it. So there must be something about it that people like. And now I'll try to show you what it is and why it's getting that popular. Since the beginning, Angular started using 3 main concepts that are still used throughout the development of the entire project. So they are still here also in version 2. First one is structure. What we like about Angular is we get some structure. We get some elements that can help us to define how to build our application. So it's not just some random code, but we get these elements and say, okay, if you want to write your logic, then you can use this kind of element. If you want to display something, then you can use that element. So we have some small elements that we can choose among. We get modules. We can reuse our code. So everything that we write it in a module. And these modules can be plugged and played in different applications, or we can share it between us developers. So this is also something very important that we expect to have today. And last but not least, we have testability. Of course, we want to test our applications. As long as they grow, the code becomes really, really hard. So we can't just open it in every browser and see if it works as we expect. So we have these testability tools. The whole framework is made in a way that it enables testability. Angular started mainly as a copy of the so-called model view controller design pattern, which was mainly used on the server, and there are still debates how it should be applied actually in the client. But what it actually evolved afterwards, it was not only model view controller, but model view anything. You can do model view presenter. There is something called model view view model if you want. So all of these 3 patterns are very similar to each other. They can be implemented with different ways, and Angular provides you. So you have the flexibility to decide how you want to structure your application. So here is a very simple diagram of how you would do one, let's say, MVC application with Angular. So you have the user, you have your view here. You interact with the view by clicking on a button. Oops, I'm sorry. And then you have Angular propagating this to your controller. Your controller will probably fetch some data, and it will manipulate the model, and this model will be bound to your view afterwards. And this repeats all the way. So this is very, very, very simple way of using it. How does it look with code? So this is very simple example of code. Most of you have been using Angular, so you have probably seen this code, or you have maybe written it yourself. We have of these factories that are basically some services that can help us to write some code that is relevant to our client application. We contact maybe our API, our REST service, and then we just provide the data that we get as a JSON. We have this controller that it communicates with our service, and it just propagates the data to the so-called scope. So scope, this is our model. This is the glue between the controller and the view that we are going to use. So that we have put our, let's say, attendees in the scope. And the way we use it is that we say, OK, this part of the DOM is going to use this controller. And then we use this special directive that allows us to iterate and repeat a piece of HTML using a specific model. This is a very simple concept. And I think this was also one of the reasons that many people like it, because it's really expressive and it's really easy to see what is happening. We talked about these scopes. I think actually scopes are one of the most difficult things to learn when starting Angular, or this is at least what I have seen based on my own experience or based on what I have seen with my colleagues or with my friends when we will be discussing about Angular. Why is it so difficult? Because the scope is some object that Angular creates for you, and you have some freedom how you work with it, but still you have to use it most of the time. The idea is that once you bootstrap your application, you get this root scope. And from this root scope object, it's a plain JavaScript object, you can create children. These children help you to slice your code, to isolate pieces of your code. And by default, these children are created in a so-called prototypical inheritance from JavaScript, which means that if in the scope, let's say scope A, you have some method, then you could access this method maybe in scope this A12, although this method is defined here. This is how default prototypical inheritance work. I'm not going to tell more about this, but we can discuss it afterwards. Or we can create the so-called isolated scopes that they just don't use the prototype of the parent, but they have their own clear, let's say, workspace with methods and fields. Components. Components, they came a bit later. The first was actually controllers that Angular was using. But then people thought, OK, controllers, they apply to the whole page, maybe, because this was the concept that we know from the server. We have the controller. It gives you access to the whole page, and then you can do whatever you want with your view. But apparently, this becomes really hard to maintain. In your page, you have different smaller parts that you want to manipulate. You don't want one big controller for them. Why shouldn't you create smaller controllers? Then you can isolate these pieces of code, these also called components. In Angular, components are called directives. We have a lot of built-in directives, and we have, of course, the power to create our own directives. Example of a directive, how it looks. We create some module, and then in this directive, basically, we return some definition of our directive. We can define how this directive should be read. We can use HTML tags, we can use attributes, we can use classes, we can use comments. So we can decide how to do it. And you see a bit weird way how this is defined, but basically this E comes from element, A comes from attribute, and so on. Here we have the scope. So here we can decide what we want in our scope. So in this declaration, I say basically that I want in my scope to have a property called to, and I want to read this property from my HTML element where I define my directive. And you see this weird sign at. Well, basically this means that I want the content as a string, whatever it is. So this was again I think it was very weird. Although there are three, we have this one, which means give me everything as a string. We have one for callbacks, let's say, and we have one for just general objects. And then at the end, we can define our template. We can define it inline, or we can maybe point to a URL, so to some external HTML that will be fetched and and downloaded when requested. And how we use this? Well, we just define our tag. We can define our property here. And when you bootstrap the application, of course, you get this heading 1, where our 2 is bound to our parameter here. Very simple example. However, this was Angular 1. It started in 2009. It developed a lot, but the web is changing. A lot of new things are coming, and we have to keep on. If we stay here and wait for a while, then we will miss it. We can't do this. We have to predict what is going to happen and to come along and propose our way of doing things. And this is what the Angular team is actually doing. They said, the web is changing, so we can propose a newer version, a better version of Angular, because it's getting so popular, we like it, people like it, so we have to help them and make it maybe simpler, maybe better, maybe faster. So this is what we're going to see in Angular 2. This here is a simple chart of showing what is happening with the web in the last couple of years. So we see that only for, let's say, for like 10, 15 years, we get a lot of changes in the web. We started like from simple web 1 through the web 2 or so-called. Then we get the semantic web. Then we are going to the web post web, and so on. So a lot of changes are going on. There are constantly new things. We have these microservices. They had really nice sessions today and yesterday. So a lot of new things are coming, and we have to embrace them in one in another way. So there are a few key concepts that Angular 2 is going to be built on. Of course, mobile. Everyone is using mobile telephone connected to the internet. I think that 99% in this room, I guess, have a mobile phone with internet connection. I leave 1% always because I think there is always one having Nokia 3310. Yes, thank you. And but this is fine, nothing wrong there. So we have to take consideration about this. What's the difference? Well, although mobile phones are kind of reaching what computers can do, like my laptop, for example, but still they operate in a different way. They have a more constrained CPU, more constrained memory. The browsers are also quite constrained. Now they're kind of reaching, of course, but we have to think about when we build our websites, because we want not only to be mobile friendly, but we want to be mobile efficient. We have the so-called evergreen browsers. What are they? Well, evergreen browsers are basically those browsers that are always up to date. And these are, for example, the last versions of Chrome, Firefox, the last version of Internet Explorer, the new upcoming mystery Spartan, etc. So these browsers are always up to date. Why is this so important? Well, it is important because not only that we get all the security fixes right away, but we get also new features of the language. So if we say that there is a new feature coming in JavaScript or CSS or HTML, well, if browsers implement it, then end user will have it right away. And this will hopefully, this is the idea, that will make our work as a developers easier, because we don't have to think about this browser, whether it supports this feature, etc. Well, I think we will still have to do it, but in the either world, this is very kind of promising. Another very important concept that is coming here is so-called web components. How many of you have heard about web components? Great, like half. So the idea of web components is that we are using today JavaScript, HTML, and CSS. We can create this isolated piece of code with JavaScript, for example, but we are still using one big file with CSS, for example. We are concatenating smaller files and doing one big file. And then when we do a change, actually we invalidate the whole file. Well, why do this? Why don't we just ship these smaller pieces of CSS to the piece of HTML that they apply to? And this is the idea of web components, that we should be able to define components. So this is going to be a standard. We should be able to define components based on JavaScript, HTML, and CSS. That's it, everywhere. And this is going to be accomplished through 4 main aspects. The first one is basically we'll be able to define our own custom HTML tags. So as we can do the same with Angular in the previous example, this will be a standard actually. So I can create a tag called Codemotion, for example, and this should be fine. I can define some attributes to this tag that mean something to my element. Then we'll have the import of 1 or more HTML documents. The same way we link to JavaScript files today and CSS files, the same way we should be able to link to HTML files. Why not? It seems logical. We should be able to do some templating. So today, if you want to do some templating, basically you would use some div, let's say. Then you set display to none with CSS, and then you use maybe jQuery or some JavaScript to copy the inner HTML, and then you can just clone this piece of HTML, right? But the idea is that we will have HTML tag called template that creates this abstract HTML for us that we can reuse. And then we can attach it to other, let's say, tags or use it the way we want to. And last but not least, we'll have the so-called shadow DOM. The shadow DOM, it basically do the abstraction, the isolation of our component. So if I create, let's say I want to create my video player, I create a tag called video. It has one attribute called source, and I can use it in my HTML just like as a normal HTML tag. But actually behind this tag there is HTML and JavaScript. It has a logic that when I click the play button, then it starts playing. When I click the stop button, then it stops playing. And this is all isolated in the so-called shadow DOM, so that it's a place in your, let's say, memory that contains all this information and abstracts basically all the places where you have your video component. JavaScript. It is one of the actually most problematic languages ever. Although it became so popular, it has a lot of problems today. Although we are already used to these problems, we know how to fix them. We use maybe some helper tools. We use things like CoffeeScript maybe to write a better code. Depends. We have found different ways to deal with this. But apparently, JavaScript is also a language. It has to evolve. And there is coming a new version, hopefully this year, which is going to take consideration of what is happening, what the problems in the current JavaScript are, and how we can make it better. Good thing is that JavaScript is that popular that besides on the browser, we have it also on the server. We have Node.js that is also really, really good. But the problem, for example, JavaScript, that we have these tons of libraries and framework. Every day I wake up and I'm afraid that there are like too many JavaScript frameworks and I can't really keep a list of what is happening. Even I have an idea to propose one game, one actually drinking game for tonight's networking session. So basically, what we do, there is 3 steps. First one, you think of just some random word, some noun. The second step, you open Google, you write this noun, and then you write JS at the end. And if you find a JavaScript library or framework, something with this, then you have to drink. So I think we can try this tonight, and we can actually make a tournament here, the same along as Code Factor and all the other tournaments. I hope it will be appreciated. So the next, the current version of JavaScript is so-called ECMAScrip 5. And when we write JavaScript, we are used to pass a lot of callbacks, let's say, because we want our components to be decoupled. And how do we decouple them? Well, we give them callbacks instead of hard references. We create the so-called classes. JavaScript is not really an object-oriented language, but it has the ability to create class in a weird way. Basically, you define a function, then use this keyword inside, and then you have to remember to use the new operator when instantiated. So there are some, I think, crazy stuff about it. Then we have this prototype where you apply there you attach some methods. we are using it and it works, although it looks weird, I think. We use modules, of course, that we want to structure our code in specific different pieces. We use require.js or common.js. There are different ways. So the next version of JavaScript, actually called ECMAScrip 6 or ES6, it is going to help us to make our life hopefully easier. So all the things that we are doing today, we will be still able to do them, but everything will be included in the language. Everything will be provided. So we don't have to do this manual editing. So we'll be able to create classes, normal class. We'll have a keyword class. That's nice. We'll have lambdas. Today we had a couple of nice talks about functional programming and lambdas. Now we have them in JavaScript. Yay. We have module system built in. So no need to worry about require.js and common.js. Everything will be provided. And many, many other nice things that are coming along with it. So how does this work? If you haven't really seen ECMAScrip 6, this is a very simple example of it. On the left side, you can see how it will look like to write a class in ECMAScrip 6. And on the right side, you'll see the same class written with the current version with ECMAScript 5. So you can see the lines of code are almost the same. The difference is that we have this special keyword class. We have constructors. Nice. You can see how we define functions then inside the class. So we just write the name and the parameters, and that's it. And then we have here, if you notice console, then we have some nice way to print strings, which is also very handy. And we use it. Doesn't matter how we write it, we use it in absolutely the same way as we are used to. Well, this is still in progress. Many of the browsers like Chrome and Firefox, and actually they have implemented most of the specification in ECMAScrip 6. There is a funny thing that Spartan, which is still very, very mythical, I would say, browser, there is a rumor that it has implemented much more features from ECMAScrip 6 than Chrome and Firefox today. But still, no one has tried it. And it's not a rumor yet. Thank you. So this is really nice. However, we need something to do it. And we can use all these cool features today in our browsers, but we need something called transpiler. One of the most popular transpilers is called Babel. And what it does is basically it takes your code, your JavaScript code, and written in ECMAScript 6, and it translates it to ECMAScript 5 automatically for you. So you can write basically with the new standard and get everything working in the today browsers. So this is handy. I'm still not using it that much, I would say, because I want to wait a bit. I'm a bit conservative, and I want to wait until it gets kind of adapted more in the browsers. But if you want to experiment or try new things, or if you think the new syntax is that cool that you can't really wait, then you can start using it today. OK, why we'll be talking about this with history, JavaScript, what is happening? Well, the idea is that all these things really important, really matter to what Angular 2 is going to be. Angular 2 is written for the future browsers, for what we are going to have probably maybe this year, maybe next year, but this will come at some point. It's not yet today here, but it will come at some point. And why is it so? Because we want, when we have these standards applied and spread all over the world, all the developers, that we could write our application. So if we start writing today our applications in Angular 2, in 1 year, when all these standards are fine, are working, then we could use our application, and it will be working. Just we can remove these things like Babel, the transpilers, or all other tools that are still transforming from the new version to the old version. So when there is a new thing, the first thing introduced in Angular was a new website. Woohoo! And it's, of course, with the IO domain. Everyone is getting this domain. I'm only waiting. I think they're too expensive, so I'll wait a bit. But they get this domain. So Angular IO, this is a new website for Angular 2. It includes some references, some videos that you can check about the new syntax and what is going to happen there. So Angular 2 is going to be actually built with ECMAScrip 6. And then we can write our application in ECMAScrip 6. No worries, you can still use ECMAScrip 5. This is totally fine. As you saw, there is this process of transforming ECMAScrip 6 to ECMAScrip 5. So if you don't feel comfortable, just forget it. It's not necessary. But if you want to, you can already start today working on ECMAScrip 6. However, the Angular team, they didn't stop here. They said, OK, we like what is going to happen with JavaScript, but we want to put something more there. And they're putting 2 new features, the so-called metadata annotations. If you're familiar with maybe annotations in Java or attributes in C#, for example, these are annotations. This is a piece of code that is describing your method or your class. So it applies to your class or not to your instance. So this is really metadata that you can read and do something with it afterwards. And then we have a type system. JavaScript and types, why not? It sounds interesting. So you could actually use types in JavaScript. You can create your classes. You could use built-in types like string, number, etc. So basically what is happening now is we have here ECMAScript 5, which is today's version of JavaScript. We have ECMAScript 6, which is building on top of it. We have the types that are building on top of ECMAScript 6, and then we have the annotations that are building on top of the types. And initially, Google called this AdScript, their new language, let's say. But from the last Angular conference that was just a couple of weeks ago, Google announced, or the Angular team announced, that they've been working closely with Microsoft. And now they're using the so-called TypeScript. So TypeScript is something like CoffeeScript, basically, that Microsoft is doing. You can write JavaScript just in a different way, and this is compiled to a regular JavaScript afterwards. So Microsoft is going to refactor this, and TypeScript will be basically the new AdScript. Nice. Woohoo! Let's see how, just a simple example, how this is going to be. So here we have our first directive written in ECMAScript 5 that we saw a bit earlier. And here we have the same directive written in Angular 2, how it's going to be. So you can see again, the lines of code actually I think are here a bit more, but we have a couple of concepts here that are very different. We have this component and template. These are basically these metadata annotations. And this component, it says basically that this class is going to be a component. And then we give it a selector. So basically, everywhere where you meet the tag, which has the name welcome, then apply this directive to it. And then we attach a template metadata. So say, OK, I use this template for my directive. And here in my class, I say inject. So this is basically dependency injection in Angular 2. And this is the type. We have this type ng element, which is the element that we apply our directive to. And in this case, I'm just reading directly the attribute. Of course, you can do this in a couple of ways. And I use it in exactly the same way here. So another important change in the Angular is the so-called change detection. We talked about the scopes and the problem of scopes. One of the biggest problems in the scopes is that when you do data binding, you're not sure that you're binding to a property of your concrete model. Because if your scope is created via prototypical inheritance, then maybe you're binding to the property of your parent. So this can be problematic sometimes, and it can cause you a lot of troubles when you're nesting a lot of scopes one in another. So now in Angular 2, scopes completely disappear. They have made a different approach in change detection. If we take a look at this simple application, so it's an application about a conference. We have search bar, we have some speaker list, we have some pager. Very simple. This can be rewritten with some model like this. So this is basically moduling our application in some smaller parts that are hopefully independent, and we can work with them independently. So change detection in Angular 2 will actually use all these small components that you are building your application with. For every component, you get automatically, behind the scene, created a so-called change detector class. This change detector class, it reads all the data bindings that you have and creates basically if-then. So it creates a function so that when you change some of the property, it checks if this property is different than the previous value, blah, blah. Why is this? Well, apparently this is much faster for virtual machines to use. In Angular 1, what their approach is that you have a generic function, generic getter and setter functions for your properties. But apparently this is problematic with virtual machines. So that's why in Angular 2, we have a specific class for all of your components. But you don't have to do anything about it. It is generated behind the scene for you by Angular. Another difference in Angular 2 is that we don't have two-way data bindings. So, which means that if you have, for example, input field and you do data binding, then you can't really do the way back to your model. You have to read the value in a different way. You have to attach, let's say, to key up event and then read the value by yourself, as we do it in the good old days. So now the change detection tree looks like this. So we have one top component, and then we have our smaller components. We don't have cycles anymore. And this is really great thing because we can reason about how data is changing in our application. We can just look at this model and see what is changing what. In Angular 1, this is not possible because we have two-way bindings. So basically, if you change one property, it may trigger change in another property, which may maybe change you again, and then you get these cycle iterations and you get an error at some point. It really gets complicated when your code grows with Angular 1 because these dependencies between models are very tempting, and you can't really, you just lose the notion of how you're referencing each other. So this is all gone in Angular 2. So we're talking about performance. So it's not about simplicity, but also about performance. The Angular team says that the new change detection system is 3 to 10 times faster. And we as developers can make it even faster. How can we do this? Well, for example, if we use immutables in our code, so if you have an object with a lot of properties, let's say a data object. So if we say this object is immutable, so basically every one property, it cannot be changed unless the whole object is changed. This automatically reduces the change detection because all these property, we don't have to check them. We check just the instance, the top instance. And this, of course, makes the whole algorithm faster. So we have this 3 to 10 times performance optimization. And we, as developers, by structuring our code, can actually increase it even more if we want to. Another big change in Angular 2 is the so-called templating. Templating means the way we define directives and we use them. As you remember, I told you that directives are one of the most difficult things in Angular 1 to start with because they give us too much freedom of what we can do. Well, in Angular 2, we have, again, this freedom, but we get it in a different way. We get three main scenarios that we are going to use most of the time. And these scenarios, they're implemented as a separate directive. So we have, for example, you already saw a component directive, which is kind of general directive for what we can do. We have a template where we can attach some template. Or we have a decorator, which is basically we attach it to some HTML element and we do some changes without changing the template. So just decorating it. And another important aspect here is that this template engine should work with web components. And web components is a very big abstraction. Web components give us the opportunity, the possibility to create our own HTML elements with tags and behavior. So basically, you have an HTML element with some attributes, and you don't know how they work. And you have to be very careful how you do data binding with it, because you don't know what they do inside. For example, if you think, if you've worked with Angular 1, you know that if you want to bind the source of an image, you don't use the property source, because the browser will actually try to make a request to your binding, and it will fail, of course. So there you have to use a special directive called engi-source, right? This is another example of this specific property. Another can be if you have just a button, you know the disable property, which disables the problem. But disable property, it doesn't matter if it has value true or false. If it is present, the button is disabled. So we can't really bind directly to properties because we don't know how they work, what they mean to the underlying HTML element. So this is something very important, and this has influenced the way Angular team has chosen to design and develop the templating part. And another like important integration point here is that if you open your code in some IDE, you should be able to recognize these components. So IDE should be able to read that this is a template and that you're using dependencies maybe to other templates. So let's see how the new templating engine is going to be. So here we have just a simple directive. It has the tag conference. I have attached an external URL. And I don't have anything specific, just a list of speakers here. And the way I use it is I just define it HTML. So now I'm going to show you the HTML of the new templating engine. And you can wait a bit, because maybe some of you get really scared. Please don't rush away. So this is it. If we take a look here about what is happening here, we use some brackets, square brackets, some round brackets. If you wonder why is this, actually this is a valid HTML. Just that we don't use it today doesn't mean that it's invalid. But it is one of the propositions for the new template engine in Angular. And actually it has a really natural meaning. We have for each instead of AnguRepeat directive. We have property binding. We have event binding. Just one of the reasons why this is it. For example, here, for property binding, as we talked about, we can't really use the source property directly, because we don't know what is happening with it. And that's why Angular team has decided to use very closer property, but different in a way. So they say, okay, we just decided to use square brackets here. And when you open this in, let's say, Chrome Developer Tools, you'll be able to see what is the value of your attribute. So they wanted to decrease the gap between what you write and what is going to be the actual HTML afterwards. So we as developers can debug our applications easier. So this was their reason, one of the reasons about it. The same is here about events. So we need a way to distinguish between binding to events and binding to properties, of course. If you want to play today, actually, one of the Angular team has created a really nice GitHub repository that you could use. It has the minimum dependencies for Angular 2, so you can actually start using it, and you can play on your local machine and see how the new templating engine is working, the new dependency injection, etc. But what is happening with other components? We remember that from Angular 1 we had services, we had factories, providers, controllers, all these things. What are happening with this? Well, basically they disappear. We don't need them anymore. We can just use normal classes, because this is what they are. if you think about it, it's the way we define now services and factories with Angular. It is basically we are wrapping a JavaScript function or class or object in a way. So we don't need it. We don't need this. We can just use our plain old JavaScript classes, and then use the dependency injection to use them the appropriate places, and it becomes really much simple. So what is the new direction that Angular is taking? It's going to be ECMAScrip 6 or TypeScript. Basically, these metadata annotations and type system, this is completely optional. If you don't like it, you're of course free to stick to the ECMAScrip 6, or if you don't like this, you can go to ECMAScrip 5, of course. But you have the opportunity to choose. We have IDE support. We can examine our code in different IDEs and see what is happening. We have integration with web components that are bringing the ability to create and share components from one place to another in the web. We have modularity. This is built in, so we don't have to write our own modules anymore. And we have better performance through the optimized version of the change detector, through the optimized version of the templating, from the optimized version of the communication between these parts. Again, from the last conference in the United States, Igor said that Angular 2 must be much more simpler than Angular 1 it is today. But is it like this? We definitely need some simplification, because we want these scenarios that we are using most of the time, we want them to be really simple, really straight to start on and play with them. If we take back about the history, overall history of Angular, it really started from a side project. It went through internal tool and Google. It went through mass develop or mass popular tool, and then we get this new version. So we can see this development from something small to something big, and there is a reason about what is happening, what is changing, and why it is changing. However, Angular 2 seems like a completely new framework, because although it has some concepts that we are used to from Angular 1, we still have to learn a lot about it. Even now, when I play with it, there is no documentation yet, not enough. There are some videos that you can watch online, or you can read the design documents of the Angular team on Google Docs. They're open, so if you're interested, you can actually read why they're taking these decisions. It's really actually interesting. But if you're starting now to learn Angular, this is great, because you can start from Angular 2, and it will be a new library for a new framework. But if you're moving from Angular 1 to Angular 2, I don't feel that there is this slight transition, smooth transition. The Angular team says that they'll provide us like guides how to migrate our code. But I don't think that this migration is going to happen straight away. It will take time. All these community projects that are written in Angular 1, they have to be rewritten, of course, in Angular 2, because Angular 2 works in a different way. And this will take time. This will take time and effort, of course. So this is not going to be as easy as it should be. That was from me from today. Please rate this session. I really love to hear from you, your feedback about it. If you have any questions, yes?
Just a question about the ID support. What kind of ID will be supported better, and some words about this?
Yes, this is actually also, I haven't really seen it in action, right, if I have to be honest. But the idea is that if you open, there was one idea that I really forgot the name about it. It's actually built-in Eclipse plugin that you could open your, let's say, project in Angular or just any website, and it will examine your HTML, let's say. And it will have this connection. It will be able to tell you that this is a directive. It has these properties, and you, as a developer or maybe designer, you will be able to manipulate it or maybe style it. If you're familiar, let's say, with if you have been working with Flash or maybe Silverlight or something like this, they have this idea that you open all your files, and then you can examine all the components in your files. You can give them some styling, etc. But this, as I told you, I haven't really seen this in action, but hopefully it will come. Well, if you don't have any questions here, you can contact me, or we can start the drinking game challenge afterwards in the networking session. So thank you for today.